Hi, everyone. Welcome to this session. Today, we're going to be talking about the next wave of Edge AI and robotics. My name is Leela Karmanathan, and I'm the Jetson Hardware Product Manager. With me, I have my colleague, Chen.
Hello, everyone. My name is Chen Su. I'm the Senior Product Marketing Manager for NVIDIA Jetson.
Awesome. Let's go ahead and get started. So today, we're going to be talking about three key things. We'll start off with talking about Edge AI and robotics and give you an overview of the industry outlook and the trends that we're seeing. Then we'll go into some cool details on how you can unlock new applications with our NVIDIA Jetson AGX Orin. Finally, we'll close with some really great Jetson Orin customer stories and use cases. So let's get started. What we're seeing is Edge AI is really transforming nearly all industries. A lot of what you can see here. From a study by McKinsey, AI could potentially deliver an additional economic output of around 13 trillion by 2030. So where do we see Edge AI? It includes manufacturing facilities where AMRs, as well as optical inspection and safety and compliance are required, retail stores that are going to be fully automated with robot refilling the shelves, or customers will be able to enjoy checkouts for self-checkout, as well as for inventory management, customer service, and customer analytics. In smart cities, we're seeing smart spaces like smart traffic lights, smart parking systems that really help make the spaces smart. Along with that, on the healthcare side of things, we're seeing hospitals are going to be able to process digital images with telepathy technologies and AI-based image analytics. Along that, on the healthcare side of things, we're also seeing patient monitoring as well as sanitization, compliance, and other medical instruments all needing more AI. On the logistics side of things, we're seeing a lot of small pick-and-place robots, and palletization is requiring a lot more AI and are requiring more autonomous mobile robots. On the agriculture side of things, we're seeing autonomous mobile robots in harvesting, weeding, as well as crop monitoring. On the home side of things, we're seeing that for everyone's home, there are more AI cameras to provide us security information as well as monitoring information. And there are even some robot pets that are helping with entertaining. And then lastly, on the metals and mining side, we're seeing unmanned ground vehicles are going to help reduce risky operations. So why Edge AI and robotics, and why now? It's kind of the three key things that you can see here. The first is neural networks have really matured. Neural networks and the related AI infrastructure have finally developed to the point of allowing generalized machine learning everywhere. Organizations are learning how to successfully train models and deploy them at the edge. Along with that, there are advances in compute infrastructure. Powerful distributed computational power is required to run AI at the edge. There are all these systems that are generating more data that needs to be processed, and that processing needs to happen on premises, on the devices, close to the action happening. And then lastly, in terms of the adoption of IoT devices, there's this widespread adoption of the Internet of Things that's fueled the explosion of that big data that I was just talking about. And so with the sudden ability to have all of these sensors, from industrial sensors, smart cameras, robots, all of them need to be able to not only collect data, but also be able to process that data and quickly deploy AI models at the edge by taking advantage of that data. Next, what are some of the macro trends that we're seeing in terms of what are the computational power required for some of these Edge AI and robotics applications? The first thing that I wanted to note is that a lot of these applications in the past may have been single fixed function devices that only did computer vision or only did conversational AI. But with the growth of data that we just talked about, we're seeing that a lot of these applications are all becoming multimodal, and they need to be able to do multiple things at once. And so with that, it's driving this need for a lot more compute power, all the way from 10 TOPS to 275 TOPS. And there's a range of applications that require varying amounts of compute power. So starting off on the high end, we see, if you look at the right of this slide, in the 200 to 275 teramillion operations per second range. We're seeing warehouse autonomous mobile robots, various unmanned ground vehicles like mining unmanned ground vehicles, as well as agriculture and more. Also on that smart city side of things, and then optical inspection. All of those are requiring more compute to be able to do a lot more processing quickly. Secondly, looking at kind of the middle tier from that 40 tops to 200 tops type compute power devices, we're seeing things like traffic flow management, surveillance and public safety, last mile delivery, as well as the home service robots and inventory management, as well as digital signage that are all requiring more compute power. And then lastly, the first tier. These are things like smart cameras, as well as drones or handheld medical instruments, a lot of the edge IoT devices, as well as smart meters and pick and palletization. All of these together are driving more compute, whether that be in the 10 to 40 top range or the 200 to 275 tops range. So what are some of the challenges that those applications see? It's what you can see here. So there are these 5 key things that we see as a common challenge in a lot of these applications. And they apply to both the edge AI space as well as the robotic space. So the first kind of relates to what we were talking about earlier, in that there's this massive amount of data. All of the sensors that exist in a lot of these edge systems are producing a lot of data that now needs to be processed and analyzed. So there were studies that showed that 175 zettabytes are expected by 2025. Next, another key reason why customers choose edge devices is to get those lower latencies. Responsiveness and real-time applications are really important for these kinds of applications. And that means they need under 20 millisecond latency requirements. Moving on to mobility. Being energy efficient as well as having a compact size is really important, especially for autonomous mobile robots, where you can't have a super large cooling solution. So you need something compact, but gives you the performance as well as in the power budget that you're looking for. The next thing that we see as a big challenge is scalability. Customers want to be able to deploy applications from entry-level to higher-end autonomous machines with minimal changes and be able to use the same software. And they also need it to be easy to use software. Along with that, they need an ecosystem to help speed up their development, whether that be for carrier boards and systems or software services. As they scale, they want to kind of enhance that even more. And then lastly, on the deployment and manageability side of things. So initially, a customer may start out with 5 or 10 devices, but then they could scale up to 100 or 200 stores, like in a retail store, for example. And so with that, they need to be able to deploy their software with minimal changes, from testing to production to all of those 200 devices without a lot of effort. In the past, for things like a washing machine, you didn't really need to update the software that often. But now, with the scale that's growing in a lot of these edge AI and robotics applications, you need to be able to constantly be updating your devices and your systems, so that way they have the latest and greatest. And with that, we wanted to show you some awesome use cases leveraging our Jetson AGX Orin. Awesome. So now we got to see some really awesome use cases. And now I'm going to talk to you about how Jetson AGX Orin can help you develop more. So the Jetson AGX Orin series is going to provide server-class AI performance at the edge to solve a lot of those challenges that we just talked about. It will provide up to 275 in-date teramillion operations per second, powered by our latest generation Ampere GPU, along with a new version of our deep learning accelerator. Along with that, the AGX Orin series will also include up to 12 A78 ARM CPU cores and up to 64 gigabytes of memory at 204 gigabytes per second. The great news is production modules are available now. You can get started today with the Jetson AGX Orin 32 gigabyte production module. Along with that, we also have a Jetson AGX Orin developer kit, and you can get started developing for the entire Jetson Orin family with that Jetson AGX Orin developer kit. So some more details about the Jetson Orin family. This slide shows our entire Jetson family. The top of the slide highlights our new Orin family, and the bottom of the slide highlights some of our previous generation products. And so we divide the Jetson family into the three key categories that you see here: entry-level, mainstream, and higher-end autonomous machines. And so we just talked about the great Jetson AGX Orin series, which provides you 275 TOPS of performance. That's 8x the performance of the previous generation. Along with that, we will also have Orin NX modules as well as Orin Nano modules. So the Orin NX, there will be an 8 gigabyte and a 16 gigabyte version, and this ranges from 70 to 100 TOPS of performance. And this is similar to what we did with Xavier and Xavier NX, where we bring Orin to that Nano 260-pin SODIMM form factor. And then lastly, we have the Orin Nano series. This is where we bring the Orin to our Nano type product. And so it comes with 20 to 40 TOPS of performance. And the great news is the Orin Nano up to the Orin NX are completely form and pin compatible. That means you can develop one application and one system to support all of the 4 modules. And so the great news is with Orin, this is the first time that we have 6 different modules for every type of application, from entry level to higher end autonomous machines, which are all based on one architecture. So this will allow you to really scale your applications easily. You'll be able to have a single system for the 4 modules on the left here, and then you'll be able to have the same software for all 6 modules. So that will allow you to really scale your applications well. Moving on to how you can unlock some new applications with Jetson AGX Orin. So the key thing to note is that the simple things do matter. So what I'm showing you here is a classroom of students where we are running a pose estimation to look at the poses of each of the different students. And so each of the images here have different resolution. So on the left, you can see a 640 by 480 lower resolution photo. Then you can see a 1280 by 720 mid-resolution photo. And then on the right, you can see a high-resolution 1920 by 1080 resolution photo. And so the left 2 images we ran on the previous generation Jetson AGX Xavier, and you can see the left images captures 18 people out of 35. The middle image captures 29 people out of 35 at 32 frames per second. And then the right image running on Jetson AGX Orin captures almost all the people, so 34 people out of 35, and it's running at a real-time frame rate of 33 frames per second. So the key thing to note is that for the same real-time frames per second, Jetson AGX Orin can process higher resolution images with more accuracy compared to the Jetson AGX Xavier. Developers can now process higher resolution images with a wider field of view. So why is this important, you might ask? Well, let's take a retail example. In a retail store, there might be a lot of cameras that are spread out, and that might cost a lot. But now that you are able to process higher resolution photos and have this wider field of view, you can save your cost by placing a camera further away and still be able to capture all of the objects that are on a store shelf or various other things that you might need and reduce your cost, as well as be able to process more pixels and process bigger models. So all of this is now enabled with Jetson AGX Orin. So along with that, Jetson AGX Orin compared to the previous generation Jetson AGX Xavier gives you this huge leap in performance. Here you can see some of our pre-trained models. Our state-of-the-art models include computer vision models as well as conversational AI. And so you can see we ran them on Jetson AGX Xavier as well as the Jetson AGX Orin dev kit. And you can see going from AGX Xavier to AGX Orin, we saw taking the geo mean of all of these models, we saw a 3x performance increase on these dense models. And something to note is when we launched Jetson AGX Xavier, compared to our latest software today, we saw about a 1.5x performance increase. And we expect to see the same on Jetson AGX Orin, that with future software optimizations like TensorRT optimizations, there will be more performance you'll get on Orin, and it will be more like a 4.5x performance increase compared to the previous generation. So along that note, Jetson AGX Orin also gets a huge jump in power efficiency compared to the previous generation. So earlier this year, in a standard industry body ML-Perf submission, Jetson AGX Orin won the inference edge category, and our previous generation, Jetson AGX Xavier, was already winning that category. And we saw on the performance side of things, there was up to a 5x performance increase, and on the power efficiency side, we saw up to a 2.3x performance increase. To show you how we're constantly optimizing our software and optimizing our models, you can see in the latest submission that we submitted earlier this month, we boosted that power efficiency by 50% more efficiency. And so with this, you can see across some of these standard industry models like ResNet50, BERT, 3D-UNet, as well as RNNT, you're getting this huge jump in power efficiency compared to before. So another key thing to note is that not only does Orin come with a GPU and CPU, it also comes with a deep learning accelerator. And this is basically a fixed function accelerator for deep learning inference workloads. It allows you to offload the GPU with some of your AI applications. So in a couple slides earlier, we showed you some of our computer vision models like PeopleNet as well as DashCamNet. And so here, what we're showing you is the breakdown of the GPU performance as well as the two deep learning accelerators. And so you can see of the total performance, the deep learning accelerator performance is about 1/3 of that. And so with this, you really get this huge jump in performance. The DLA compared to the previous generation DLA gives you a 9x performance increase. So overall, the DLA can really help you offload your GPU and free up your GPU for more compute-intensive applications. So next, I wanted to talk to you about Isaac Ross and how we're using Isaac Ross with Jetson Orin. So the Jetson Orin platform is designed to solve the toughest robotics challenges, and it brings accelerated computing to over 700,000 ROS developers. Combined with the powerful hardware and capabilities of Jetson Orin, enhancements in our latest NVIDIA Isaac software for ROS put unprecedented performance and productivity in the hands of roboticists. So what are we doing? The new Isaac ROS DP release optimizes the ROS 2 nodes processing pipelines, which can be executed on the Jetson Orin platform. And it provides new DNN-based gems designed to increase the throughput, like you can see here. There's image segmentation, as well as proximity segmentation and stereo disparity. And you can see we've run the previous version of Isaac Ross EA3, as well as the Isaac Ross DP run on both Jetson AGX Xavier and Jetson AGX Orin. And you can see with this on the dope, you can get up to 3.4x, and on the stereo disparity, you can get up to 2.2x. And there'll only be more optimizations. The other thing that I wanted to note is that with the ROS 2 release, it improves the performance on the compute platforms like Jetson Orin. So with this, the features and the type of adaptation and type of negotiation, eliminating software overheads and improving performance of the hardware acceleration that's available with Jetson Orin. So NVIDIA does this with an implementation type adaptation and negotiation that's called Nitros. These are ROS processing pipelines that are made up of Isaac Ross hardware accelerated modules, like what you can, the gems that you can see on this slide. And that's added to NVIDIA's latest Isaac Ross developer preview that I've been talking about. Next, I want to talk about some of the other accelerators that you can take advantage of on Jetson Orin. That includes the Programmable Vision Accelerator, which is dedicated for offloading some of your computer vision applications. This PVA contains a dual vector processing VPU. Along with that, there's a video image compositor that enables support for various image processing features and an optical flow accelerator. This has a hardware accelerator for computing optical flow as well as stereo disparity between frames. So what types of applications can you run with these accelerators? So common computer vision applications on the PVA include things like the feature detector, feature trackers, object trackers, stereo disparity, as well as visual perception. We just talked about the huge advances you can get with Isaac Ross and run stereo disparity. And now what we're going to show you is not only can you do that on the GPU, but you can also do that on the 3 accelerators. So here on the right, you can see the table where we've run it on Jetson AGX Orin, Jetson AGX Xavier, and then on Jetson AGX Orin with the PVA plus the VIC plus the OFA. And you can see the combination of the 3 accelerators has higher performance than the Xavier. So you can offload a huge portion of your stereo disparity onto these accelerators, freeing up the GPU for other applications. Another key thing that we see customers using some of these accelerators like the PVA for is the Harris corner detector, which is supported by our VPI software. So the table highlights the latency on a 1920 by 1080 high-resolution image with a grad and block size of 3. And you can see the very low latency of 4.59 milliseconds. So the PVA is optimal for offloading these kinds of applications because it's really power efficient and it can free up the GPU for other workloads. Next, I want to talk about how you can speed up your development. Our partners have released systems that are ready for production with our AGX Orin modules. So all the systems that you can see here, you can take to market and go to production with. And then not only do we have hardware partners, we also will continue to have camera and sensor partners and connectivity partners and software and distribution partners. So all of the partners listed here are ones that are already adopting Orin and are going to help accelerate your time to market to quickly go to market with Jetson Orin systems. And with that, I will pass it over to Chen.
Thank you, Lila. Ever since we launched Jetson Orin platform earlier in March, it has been widely adopted by 1,000 more customers in just 6 months. We have been seeing tremendous of application deployed in the field of industrial, retail, agriculture, smart city, healthcare, and more. Today, I'm happy to share some of those unique customer stories and how people use advanced computing provided by Jetson Orin platform to solve the most challenging problem in various of industry. The modern agriculture has many complex challenges. To be successful, skilled farming workers need to fight against time-consuming processes affected by many factors: temperature, climate, soil properties, and water, and the list goes on. Verdant is helping farmers reimagine their entire operation to improve efficiency, land stewardship, crop management, and profitability. Their superhuman farming technologies create a digital twin of each plant for real-time decision-making and able to reduce chemical usage by up to 95%, saving money while producing organic food for every meal. Verdant helps farmers unlock the potential of farming using microarray technologies. Equipped with multiple 4K cameras, Verdant developed the entire AI perception, action, and control system based on the Jetson AGX Orin. As you can see in this graph, we are showing you how the AI pipeline has been accomplished. Starting from their camera sensor, they have a multiple of 4K cameras processing footage and sent to image signal processors, and then complete the encode, object detection, and various of AI models, and eventually drive action and real-time planning. And the unique value that Jetson added to their whole system are following. First, Jetson Orin provides them 275 TOPS performance to run concurrent ML models, such as classification and segmentations. Second, they were able to process more pixels for each inference compared to the previous generation product that they use, Xavier. As consumers enjoy the convenience and delight of online grocery shoppings or takeouts, the challenges of last mile delivery logistics become the bottleneck of efficiency and further improving customer self-satisfaction. Meituan is taking the next generation autonomous driving technology into a very small unmanned ground vehicle with L4 autonomy, improving the safety and efficiency. Thanks to the scalable Orin architecture, Meituan can build up to 4 Orin chips and delivers a mind-blowing AI computing power at the edge, up to 1,016 TOPS, and processing up to 20 GB per second sensor data in real time. Meituan were able to prototype the technology rapidly with extensive Jetson ecosystems and a user-friendly NVIDIA software toolchain earlier this year. Here I'm showing you Meituan's whole technology stack. Enables hardware, software, and cloud services. As we've seen, they were able to run a small autonomous driving system in such a small form factor. On the hardware level, they were able to process high-fidelity camera, LiDAR, radar, GNSS data, IMU, and more. And on the software layer, multiple AI models such as procession, localization, mapping, prediction, planning, and control, even the human-machine interface can be run on the software layer. Meituan also added a cloud services on top of the powerful UGV for mapping, data updates, and fleet monitoring. And the value that Jetson added to Meituan's development is huge, and putting the whole L4 autonomy stack in a very small form factor, 80% smaller than the x86 IPC-based solution. They were able to cut 40% of cost and 70% power reduction from the x86 IPC-based solution, aiming at 60 watts per 60 watts, and they were able to support for 1 to 4 modules at the same time. More performance per dollars compared to the last generation of Xavier's module as well. They were able to get more throughput with less money they spend here. And of course, as Lila mentioned earlier, a key factor that people use Jetson is being able to run many different AI models on DLA and other processors, and they were able to efficiently use them. In the end, a lot of the modern AI neural networks are being supported by NVIDIA Jetson, such as transformer, quantization avoidance training, and LiDAR 3D models. Mining has been a very dangerous job for ones to take. Safety, personal health is the most challenging problem to solve, along with environmental pollutions. Tage iDriver has launched a unmanned transportation solution for smart mining, dedicated to providing safe, green, efficient, and economical services for open pit mines. In a very unstructured and harsh environment where the autonomous mining truck is operating, they were able to deploy complex neural network to achieve accurate perception even in rainy, snowy, and high dust scenarios. The value they provided to this industry is phenomenal, from both reducing the fatality rate and improving the operation efficiency, and also digitalize the entire mining operation. And as safety is the most important factor in their solution, Tage uses a dual Orin system, one for the autonomous mining truck system and the other for redundancy and safety. Tage also takes an outside-in approach to enable roadside coordination system, basically monitoring traffic, perceive the environment through LiDAR and camera, and detect the type of vehicle and speed, and also sending those information back to the truck to dramatically improve the safety. And Jetson added a lot of value in their solution. For example, they were able to achieve high-speed data sharing with 4G PCIe Gen 4 and also 10 gigabyte Ethernet. We also support for up to 4 Orin theoretically, and they use 2 AGX Orin design, providing up to 550 TOPS of AI performance. They also try to use vision-based safety algorithm for this harsh industrial environment to improve the final result. And also they build the whole end-to-end edge to the cloud pipeline for fleet management and performance analysis. If you have ever used a Roomba consumer robots to clean up your room, have you ever imagined the similar concept to be used in a much more complicated system to automatically clean up our street? Koa robots collaborating with LCFC delivers the solution that allows cleaning truck autonomously clean up the road, but in a large scale, with up to 1,000 driverless vehicles running in real time. Their solution not only takes cities cleaner 24/7, but also provides superhuman capabilities in identifying, classifying, and sorting individual items on waste streams, which gives over 95% accuracy. And their whole edge to cloud system is largely supported by high-speed I/Os offered by NVIDIA Jetson Orin, which enables 5G connectivity for over-the-air updates, auto-labeling, and video storage. They were able to process 12 MIPI CSI cameras and a couple of LiDARs concurrently at the edge, and their dual Orin system enables highly complex AI models such as segmentation, passenger detection, obstacle avoidance, visual SLAM, and also the planning through a GPS navigation. The next one is about our home. The pace of the life is getting faster every year, which can lead to greater stress. People sometimes feel depression and lonely, and mental health become a serious social problem. And intelligent dog-like robots from Hashibot can meet the various human needs, from entertaining the household to dancing with music. A super perception planning system that they built here is able to view the environment 360 degree and identify the surrounding factors anytime, anywhere. And they were also able to intelligently interact with human beings in the household. For example, recognize the scene, recognize different people, objects, and being able to emotionally connect with people and give actions based on the command. And how they make it possible? And this diagram shows you their whole technology architecture. And Orin plays a huge role in developing these robots because Orin support for the ROS and ROS2 natively with highly optimized and hardware accelerated package from ISIC ROS. As Lila has explained earlier, those packages will help improve the throughput of many common use robotics algorithms performance. And the ability to process those multimodal applications is the key. And you don't need to sacrifice in performance with a specialized, because Orin provides specialized AI processors such as DOA, PVA, VIC, and OFA. Eventually, all of those data concurrently being processed and shared on the 64 GB LPDDR5 memory, and we give the high-speed processing power to remove those bottlenecks. The next one is really interesting. It's about how we solve the problem that our Asian people have looked at the sky and trying to wonder. Thousands of the asteroids and hundreds of millions of undetected pieces of space junk exist in our local space environment. It's really hard for any human beings to accurately count and monitor them with a single telescope due to the weather and cloud coverage. Our Sky is building a global platform to solve this problem by coordinating the space data collection, processing, and those applications, and also being able to coordinate the entire sky globally 24/7, 365, with better than human analysis and interpretation of this data in real time. And let me show you how they do it. And with the data they collected from the telescope, our Sky team can utilize powerful AI model to process and analyze images and videos right at the edge. And you can see here their architecture diagram indicates their complex image processing flow powered by the Jetson Orin NX. And a great value adding Jetson give to them is to start development even before Orin NX module are available. And how did they do this? With the emulation feature provided by the AGX Orin developer kit, they can quickly test the feasibility and the performance of Orin NX for their workloads, and build the entire AI pipeline surrounding topics such as asteroid detection, space junk detection, and other astronomical events. As you can see, a lot of examples that I shared with you earlier around the robotics and autonomous machine. Another common edge AI task that people really want to address is vision AI development. This can be a time-consuming and error-prone process due to the lack of data and complex open-source model selections. NVIDIA offers an end-to-end software stack to accelerate the process. Starting with generating AI model, developers can use NVIDIA Omniverse Replicator to generate synthetic training data rather than using a human-labeled dataset. More diverse training data generally makes for a more accurate AI model and save time and money. The later step is to training the model. NVIDIA provides pre-trained model which uses highly accurate and optimized models out of the box for developers to start with. Then they can feed their customized data for transfer learning and simplify the model tuning and optimization with NVIDIA Tau Toolkit. The next step is building the model. In this step, the developer needs to leverage great application framework to save development efforts. NVIDIA offers video storage toolkits to easily manage camera and storage, and the DeepStream SDK, TensorRT, Triton to optimize system throughput. And you can even build your own cloud-native application with Metropolis microservices. And in the end, enjoy a quick and easy to deploy process with NVIDIA Fleet Command and manage it on any public and or private cloud. So let's double click and zoom into the third pillar here, which is the building block. In the building process, AGX Orin is a key pillar to drive high performance throughput. And the key here is in the centerpiece, the DeepStream. With 275 top server class AI performance, developers can easily build multiple use cases, running them concurrently with DeepStream SDK at the far edge. And the value add of Jetson Orin is huge. As you are free out your time on building complex AI pipelines, you can focus on your own segment apps and improve your model accuracy over time. And the whole edge to cloud journey just make it easy for a continuous improvement and continuous deployment. Let's show you a few examples how NVIDIA Metropolis ecosystem partner to build state-of-the-art vision apps on Jetson Orin and how they get the best out of it. The first case is actually a retail use cases. Today, convenience stores are the hub for shoppers in local community. Due to the large traffic and crowded environment, it is challenging for retailer to understand the shopper's behavior and optimize the stock inventory. Building their whole solutions on AGX Orin and over 10 fisheye cameras, AWL moved all their AI workloads from the cloud to the edge with better performance and less latency. They were able to run multiple AI models such as people counting, cross-camera tracking, and also the shelf inventory monitoring. And essentially, Orin helped them reduce the total cost of ownership by 4x for vision AI applications. And the next one is in the industrial and logistics setting. In the logistic industry, scanning label and barcode is an essential step to document the delivery process and give customers updates in real time. At speeds over 15 miles per hour in the warehouses and distribution centers, AGX Orin makes it possible for coil readers to boost throughput by 3x, and the process multiple labels from a single carton in the real time. This included not just the barcode scanning, but reading the label text and visual data to complement barcode scanning to boost accuracy. The higher compute power of Orin helped them add an additional classification model to the mix when compared to the last generation of AGX Xavier. And the result is to have 99.2% accuracy after removing automation anomalies. Okay, this use case might be related to everyone. Have you ever gotten the wrong takeout order from a restaurant? I have that experiences happened a few times during pandemics. It was a bummer, isn't it? Restaurant workers need help when they are multitasking with food preparation, order intake, order sequencing, assembly, packaging, and Satis AI thrives to solve this problem by running models for food recognition in order to verify order fulfillment in quick service restaurants. As this whole AI pipeline needs to run over 12 cameras, they were able to fit all the data footage into one Jetson Orin appliance, which was previously only possible using GPUs in the cloud. Orin helps them move analytics to the edge and reduce the overall cost and latency. And in the world of smart city, the traffic tower needs to help the autonomous vehicles by providing them the necessary information for potential safety hazard and optimize the path planning. This is called L4 control tower, or sometimes people refer to it as roadside coordination system. This mesh network of sensors and computers placed on the infrastructure around the facility help capture an unobstructed view of the environment. Powered by AGX Orin, Soar Robotics L5 control tower collects 3D data from the environment using cameras and LiDARs. And their primary computer vision and deep learning based AI model analyze the data, determining the most efficient and safest path for vehicles within the covered area. And how many people are there in the shopping mall and travel from one store to another? This is probably $1 million problem that mall owner wants to know because they want to optimize traffic for their tenants. Running people counting, attributes analysis, dwelling time analysis, visual cortex is able to use Orin to understand those information in real time and create dashboard to support decision making. The model achieved 98% accuracy and 8 times better performance compared to the previous generation edge devices that they use. With that, it drives our talk to the last slide. In the last 45 minutes, we briefly introduce you the trend of the industry, how Jetson Orin is uniquely positioned to solve common challenges, and we also give you more than 10 Jetson Orin stories from various industries. I'm super pumped by the achievement our Jetson partners and customers have accomplished with Orin platform and how it's truly transformed our day-to-day life. No matter where you are, what industry you work for, I believe the future of AI is really coming. Do you want to join the next wave of edge AI and robotics? Start your development today with AGX Orin Developer Kits. Powered by one Orin architecture, you can use it to develop for 6 Jetson Orin modules, delivering AI performance starting from 20 TOPS to 275 TOPS in such a small form factor and power efficient manner. Again, thanks so much for joining us today in this session. I hope you enjoyed today's talk, and we'll see you next time.